Alright, we're going to look at asynchronous counters, also referred to as ripple counters. Where it gets the ripple name is that this frequency is actually sort of rippling through the circuit, and what that means is sort of like when I drop a rock in a lake, I get the big wave closer to where the rock fell. So here I have my 16 hertz, which is my big wave, right? Going into my frequency divider. When it comes out, it's a little smaller. It's actually half the size at 8. Goes to the next one. Now I have 4. Goes to the next one, now I have half of that, which is 2. Goes to the next one, now I have half of that, which is 1. And so, but what's happening is that it has to go through this one to get to the next one, to get to the next one, to get to the next one. What that causes is something called propagation delay. So if we look up here, and I look at it between 3 and 4, you're going to see a little bit of a flux right here. You see that little bit that showed up there. What's going on is that there's a little delay within these gates. So when it went from 1, 1, 0 to 0, 0, 1, what happened is it actually had a little residual effect where we saw a little bit of a 2 in between the two. If I look into the oscilloscope, right, we can't see it right now, but if I got really, really close on these lines right here where they're all changing, what you would see is that this one would be slightly in front of where that one is, wouldn't be, just a little bit ahead. Okay? But what's going on is, notice right here I've got 0, 0, 0, and if I scoot this over, I've got 0, 0, 0, 1. We're talking about the top being 1, the bottom being 0. Scoot over a little bit, I get binary 2, which is 0, 0, 1, 0. And so forth. It goes all the way down to where we have right here where it's binary 15, 1, 1, 1, 1. Alright? Now, what we're going to do is, clocking these is actually a very valuable thing to do. What I'm going to do is I'm going to take the outputs, which are from my cues here, and I'm going to either invert them or not invert them. Alright, if I invert them, I'm going to think of it as a binary 0. If I don't invert it, I'm going to think of it as a binary 1. So, I'm going to connect here, and this is actually a mod 16 counter. I'm actually going to turn it into a decade counter, and what that means is it's going to count from 0 to 9. Alright, and I'm actually setting it here to be reset on binary 10. So I'm going to think of these as all binary numbers. So in other words, when I have the true value going in, that's a 1. When I have the inverted value going in, right here, I have a 0, 1, and 0. And the reason I have binary 10 and not binary 9 in there is because these clear circuits right here, they don't rely on the clock. The second they get hit, it causes that to go into a 0. So the second it gets there, we're not even going to see the 9, it's just going to go straight to 0. So let's run it straight through. I'm at that 3. I'm at 4. We probably won't even see this light change. 6, 7, 8, 9, and then we're going to go right back to 0. Alright, if we look at our oscilloscope, you will see a little bit of a spike right there, but this is really just picoseconds wide, and it's kind of crazy that it even shows up on our oscilloscope. If I wanted to do something a little bit more fancy, and let's say I wanted to make it count from 2 to 9, right? What I would do is I'm going to think of these presets as setting something to 1 and these clears as setting something to 0. So binary 2 would be, again, I'm thinking of this as binary numbers. So if I need binary 2, it would be 0, 0, 1, 0. What I would do is I would delete this input right there. I've got to turn the circuit off. I delete that input there. I would take this one away. And I would end up taking my preset all the way to my clear circuit here. So let me find a good hole. There we go. And my clear, I would end up taking up to my power. So let's run this real quick. And so we are going to see it go through the 1 and 2 steps right now, just because it has to get up to where it starts to reset. But let's see here, 6, 7, 8, 9, and now it's going to reset directly to 2, and what it's doing is just really loading it in, because instead of clearing this one out, it's setting it to high. And that's what's neat about asynchronous counters, is that we can make it start anywhere and really end anywhere that we want.